Today I'll be talking to you about ETA. ETA is the process that it takes from something to leave the origin and to arrive at the destination. Now, which seems a very simple problem, is actually a complex issue to address. And there's two main aspects for that. One is you want the data and the output and the predictions made to be most relevant, and to do that you normally have to have real-time streaming data coming in from your edge devices, and they may be your trucks, they may be where the consignment is in its freight, it may be flights where the flights are, it may be where your consignee is handing over the shipment, or where you're taking delivery of your new van, or what it is. But you're going to want to have to collect a lot of information from a lot of data sources, and some of them will be in real time, and you need to build a comprehensive data lake and strategy for bringing that data in. And once you've got that data in, you're going to use it for two things. You're going to use it for real-time hot data for inference, so you can make those latest predictions, as I said before, and also building up your back catalogue of data, historic data, and that will allow you to improve your models over time. So that's the first thing. The second thing to talk about in terms of ETA and complexity is ETA is normally a multi-legged approach, and we'll go through a number of transitions on that journey. So it may go from land, sea and air, and it will transition between the two. And when it transitions between the two, there might be factors to take into account, such as if you are landing a consignment in an aircraft at an airport, there may be, and it's travelled internationally, there may be customs that has to be processed, and that customs may have a fixed demand. It only will do a certain amount of packages a day, and it may be only operating certain hours, and it may be only certain days, and so you want models to reflect that real world nature of those complexities in that. So it's normally a multi-legged approach. So they're the two big things we find when we have produced ETA for people. Now, today I'm going to show you just quickly the tool. It is a simplification of that, so this is only a one-legged journey, but I just wanted to show you quickly how the tool works so you get a bit of a feel for it. So here we can see a journey from New York to San Francisco, a journey that takes just over 5 hours across the whole of America. Now, we can see that on average it does take about that here, but we can see down the bottom there's variations. It's nearly 6 hours on the 2nd of December, but it drops down to nearly 5 hours on the 23rd of December. Now that's also quite important. Obviously, you were talking about Christmas, and that's why this is better than just pure means and normal calculations. This model is taking into consideration the past performance, and it knows that around that date it's Christmas and there's going to be a lot less freight and traffic happening, so that will impact and change the nature of the model. So we can see that, and I'll now show you just a different route so you can change it and see it working. Okay, so we're now going from Houston, Texas to Boston, and we can roughly say that takes 4 hours, and again we can see the variation in some days it takes more or less than 4 hours, some day it takes closer to more like 3.5 hours, and you can just see that variation. So this is our ETA tool that we've built, and it just allows business to tackle those problems around how soon and how long it's going to take to get stuff through their supply chain, or how long it takes them to deliver to their customers. So ETA is a really important subject. I hope you've enjoyed this demo. If you want any more information, just reach out to us at Infinite Wisdom. We can give you this as a live demo, and also give you more information about some of those things that you need to consider. And let's talk. Bye for now.